Today we're going to look at finding inverses of functions. There are 4 steps for finding inverses, and really step 2 is the actual process of finding the inverse. So they are going to give us something that looks like f of x equals something. Our first step is to change f of x to y, so make it y equals 2x plus 5. Then the actual process of finding the inverse is you switch the x and the y. So y becomes x becomes y. And then you use your algebra skills to get y by itself. So you'd subtract 5 on both sides and then divide both sides by 2 to end up getting x minus 5 over 2. And then to make it look like an inverse, you use this notation. This notation means f inverse of x. This one means f of x. F negative 1 means f inverse of x. So my final answer would be f inverse of x equals x minus 5 over 2. Now, I went really fast through the process of going from 2 to 3. We're actually going to do that process together on the next slide. Okay, so step 1, f of x is a fancy way of saying y equals. So change f of x to y, because really f of x and y are the same thing. It's just a label. Step 2, change your y to an x, change your x to a y. That is inverting the equation. It's switching the 2 letters. Now our goal is get y by itself. What should we do first to get y by itself? That's right. We should subtract by 3. Don't everyone tell me all at once now.
They subtract by 3.
Hey, thanks.
Hey, you kind of have an intro. You start with "so today" a lot.
I do. Are you watching all my videos right now?
No.
Okay.
It just kind of occurred to me.
All right. Once we have x minus 3 equals 2y, we need to divide both sides by 2. You just divide the entire left side by 2. So we have x minus 3 over 2 equals y. But I'm going to put the equals y over on the left side. So that was the process of getting y on a side by itself. Step 4 is use the actual function notation, the inverse of the function. So f inverse of x equals x minus 3 over 2. Inverses undo each other. Subtraction is the inverse of addition. Division is the inverse of multiplication. Square roots are the inverse of squares, and so on and so on and so on. So if you look at the original problem and the inverse, I want you to see the similarities, how they're kind of opposite of each other. So in the original, we have plus 3. Notice we have minus 3 in the inverse. In the original, we have times 2. Notice we have divided by 2 in the inverse. So the 2 functions should look like opposite versions of each other because they will end up undoing each other. And to tie this into what we did yesterday. Yesterday, we did g of f of x or f of g of x. If we did f of f inverse of x. If we put this inverse function, x minus 3 over 2, inside the f function, all of the stuff would cancel each other out, and we'd be left with simply x as our answer. The divided by 2 and the times 2 would cancel each other out. The minus 3 and the plus 3 would cancel each other out, and you'd be left with just x. All right, do you want to try b on your own? Why don't you start b on your own and then pause the video, play it in a minute once you get stuck or once you're done. So your first step is to change f of x to y. Your second step is to attempt to get y by itself. Your second step is to switch x and y, sorry. And then your third step is to try to get y by itself. So we would add 7 to both sides. And how do we undo an exponent of 3? How do we undo a cube? Take the cubed root. So the cubed root of the right and the cubed root of the left. So we have the cube root of x plus 7, and that equals y. Our fourth and final step is to change that y back to function notation and use the inverse version. F inverse of x equals the cube root of x plus 7. The graph of F inverse is a reflection of the graph F over the line y equals x. Think about it. When we're making an inverse, we switch x and y. So look at this point AB. If we switch x and y, that point will become BA, and that will reflect that point over that diagonal line. So if I knew that this point was the point 1, 2, right 1, up 2, I could go right 2, up 1, and find that inverse point on the inverse function. That's a little low, sorry. It goes like right about here. So let's do that together. We have this graph. We need to sketch the graph of the inverse function. Now, if I ask you to do this on a test or a quiz, I will put actual points that are like fairly easy to see. This one is a little bit challenging. Well, here's the point 0, 0. Let's look at points on f of x and points on f inverse of x. So if I've got the point 0, 0, on the inverse, we would switch x and y. So what would 0, 0 become? 0, 0. So the point 0, 0 is going to be on the inverse. We will need to make sure that our graph goes through 0, 0. We also have the point 1, 1, which will also be 1, 1. So our graph is going to need to go through that. But if we reflect this over that diagonal line, do you see how this is probably going to curve like that on the inverse? And then it'll curve around to get to this point, -1, -1. It'll curve around that way. And then it'll arch like that and like that. So there is the inverse function. Let's look at the point like 1, not 1, sorry. 1.2, 3. 1.23, that's about that point. What would 1.2, 3 become on the inverse? Switch the x and the y. 3, 1.2. So write 3 up 1.2. There's about where that point is. You could do the same thing on the other side. Pick out a point. Now, if I gave you this on a test or a quiz, I would give you a graph that looked something like, I don't know. I would say reflect that or find the inverse of that and give you actual points that you could switch around and plot the new points. I wouldn't give you something weird and funky looking like that. Okay, on this assignment, numbers 13 through 16, 23 through 26, starting on page 573.